Then comes your network access control. Network is a key attack vector to secure. Now it is, you can say in a Linux system, it is one of the most important attack vectors in the network. Now network access control, that is the controls that restrict access to the local resources based on IP address of the network system. Attempting to access them are there for the import tool in Linux security. Now Libwrappers and TCP wrappers are also a key tool to check access. You can go to the net and find out what is a wrapper if you need more definition. Before allowing connection to the service, TCPD first evaluates the access control. It is defined in this particular file /etc/host.allow or in /etc/host.deny. Now, when this comes, I will relate a particular example for you. In network access control, we were in an audit of a corporate environment with more than 3000 users. Now, once we had gone for the audit, we are made to wait for a couple of hours because the people in the IT department did not want to have somebody come and pinpoint that they were wrong. So audit is always a hated job because nobody in the organization would like to be audited. You yourself, myself would not like to be audited because we don't like somebody coming and telling us that we are wrong. So similarly, in this organization we went, so we were made to wait for 2 hours. Now I got impatient. So the place where we were sitting, that was a work table where the person who had working there was absent for a long time. There were desktops everywhere and this particular desktop was also there on this table. Now the reason that they gave us is it will take us a long time to configure because we have to give your laptop an access to actually get connected to our network. We do MAC based filtering. So then what happened is we tried to connect the laptop. It couldn't connect to the network. The DHCP was not assigning an IP address. So the system in place was a Dell. Dell has a habit of putting even the affixing the MAC ID on the desktop. So the process became very simple. All you have to do is copy that MAC ID, replace the MAC ID in my laptop and plug in the network. Immediately we got access. We were able to get the IP scheme, what the DHCP server address is, what is the gateway address, and we started working on that system. Now after another hour, the guys from IT came and said, okay, your access is ready. So then for that we told them that we already got an access, an hour back, we took it. Now this is what happens when we talk about network access control. You need to really secure your system so that these kind of incidents also do not happen. Now the advantage for the company or the positive thing that happened for the company is, since we were security auditors ourselves, the objective was not to exploit the system or to bring down their services. The objective was to show them that this could be possible and to show them that we can take access irrespective of whether you are going to give it or not. So we continue with our job. So this is very important when you design networks, that not only your user access on the local system or on the servers, but the network access controls also have to be implemented thoroughly. It has to be analyzed, it has to be tested, and then it has to be implemented. Then using IP table for local firewall rules. This is again in case of Linux. Linux kernel's native firewall mechanism is netfilter and IP table. Now you can configure IP filter or IP tables or netfilter on the server. You can configure it on the desktop also. Now generally what it does is, for a personal firewall use, it will allow the incoming request to a specified services. It will block all other inbound service requests. It will allow all outbound or locally originating requests. Now there are automatic rule generators also because it becomes difficult to configure each and every item. If you need greater security, if it is a very high security area, then you need to manually configure the services, the ports that you need to allow or deny. Then comes the antivirus software. Now historically Linux was or is not as vulnerable to virus as their Windows counterpart. Windows was targeted more due to the popularity, due to the market share, because so many users of Windows are there. And then prompt patching of security holes has more effective for worms. Viruses abuses user privileges. We have seen all this in domain 3. Then you should use only non-privileged user account, so then the chances of being exploited are remote. Now as the popularity of Linux also grows, means the exploits also will grow. So you need an antivirus software that will be required for your Linux. Traditionally, anybody running on a Unix system, Linux system, including myself, we used to install CLAM antivirus on the server just to be on the safe side and also to satisfy the requirement of auditors who come to the organization that do you have an antivirus software installed. We tell them no, we are using Linux, so there is not much threat in Linux for having an antivirus software, so they put a non-compliance. So then to satisfy the auditor's requirement, to satisfy the regulatory requirement, and also nowadays since Linux is growing in popularity, to secure the system, lot of antivirus softwares, both freeware and commercial, are available for Linux. When it comes to user management, we'll have to follow certain principles, certain practices. Guiding principles in user account security is be careful when you are setting the file and directory permission. Use groups to differentiate between roles. Use extreme care in granting or using root privileges. Now we have seen in the earlier slides that how a file permission can be given, whether it is read access, write access, execute access for the owner, for the group, for others. So we have seen all that. So you need to be clear on what permissions you will give to what user under what group. So and most important thing again, the root takes it all principle you will have to keep in mind and say use extreme care in granting or using the root privileges. Then password aging. You need to set maximum and minimum lifetime for user passwords. Like we discussed a little while earlier, whether it's going to be 15 days post change, whether it's going to be 30 days, 45 days or 60 days. Generally the practice followed for admin accounts is every 15 days. If it is a bank, for the user accounts it's every 30 to 45 days. If it is a normal user account in a corporate, it may be 60 days depending again on the criticality of the information. And in Linux it's globally changed in /etc/login.defs to change the password setting for existing users. In command line you can put the change. Now if you really need to learn more about Linux, that's people who are not aware of the Linux operating system, what I would suggest is the most easiest Linux to learn is Ubuntu. So download a copy of Ubuntu, have a VM setup on your system, install your Ubuntu server or Ubuntu desktop, play around with it. I would recommend a text-based version because you will come to know about the commands that are used in Unix, which is very important to work with Unix. You need to remember a lot of commands. So you try it out so that you will come to know what the security features are available in Linux and how you can set up when you install, how you can set up the security features. And there are abundant tutorials available on the net for Ubuntu. The user community has put in a lot of documentation on different aspects, how to install different files, how to delete, how to uninstall, how to install the antivirus, webmin. So many resources are available on the net. So I suggest, if you have not worked with Linux, or if you are a novice user of Linux, you have to get started with installing a VM and practicing, because in information security you will definitely encounter a lot of systems which work on different flavors of Unix or Linux. So you need to at least know how you go and view the logs on a server, how you will go and check whether root is enabled. So the fundamental things of Unix you will have to learn to be successful in the information security field, especially on text-based servers. Now, root delegation is another aspect. SU command, it allows the users to run as root. So if you use SU with the -C flag, it allows you to run a command instead of an entire shell as root. So you must provide a root password for you to do that for SU. The drawback is many people will know the root password if you are going to allow this. Now, SC Linux RBAC, rule based access control, can limit the root authority, but it's very complex. Now, there is another command called sudo which allows users to run as root, but you need only the user's password and not the root password. Sudoers are defined in the etc sudoers file. You can open and configure the sudoers file using vi sudo, but again, when you are editing the sudoers file, you will have to be really careful on whom you are giving the permission and what level of permission you are giving, so that the system is not compromised. Now, in login, Linux logs using syslogd or syslog-NG. It writes the log messages to a local or remote log files. Like we discussed again, a SIEM tool is basically a log management tool with additional capabilities of analyzing the logs, correlating the logs, and giving a report. Nice fancy report based on PCI DSS, based on OWASP, or based on other regulatory standards. Now, you need to have a SIEM tool because it simplifies the aspect. The Syslog works on port 514, so does the SIEM tool. So the Syslog-NG is preferable because it has a variety of log data sources or destinations. It is much more flexible rules engine to configure. So you need to, suppose you have a Syslog server installed, you need to send data or the logs from your routers, your firewalls, your managed switches, the servers, and some of the critical desktops. So you need to have a wide variety or flexibility for the rule engine to be configured. So Syslog-NG is preferred for that because it is flexible. Then you'll have to change default logging settings on both the server and the Syslog-NG. Then log files management. So you will have to balance the number and size of log files. Again, like we discussed earlier, what needs to be logged is more important. Whether you want to log only the success entries, only the failure entries, success and failure, system errors, application errors, network errors. So you need to actually balance the number and size of the log files. In a typical organization like a bank with say around 400 to 500 branches spread throughout India, assume that they are enabling logs of Oracle or MS SQL, or the operating system logs, your router logs, firewall logs, switches logs. Now, the average consumption per day in terms of log requirement will itself be more than 5 to 6 TB. I have myself seen that a few years back, maybe 3 or 4 years back, when you enable even the minimalistic configuration to be logged, it used to actually take around 3 to 4 GB of space. So you need a large data bank or storage space to store the logs. So there are a lot of issues in that. So you need to be careful on, you'll have to balance the number and size of the log files. then you will have to rotate log files and delete the old copies, which is the log rotate. Logging itself is not a proactive control because log only tells you about the things that have already happened. It is an aftermath, or it tells you what has already occurred so that you can prevent it from recurring again. But effective logging helps ensure that in the event of a system failure, system administrators can more quickly and accurately identify the cause, therefore effectively focus on recovery and remediation effort. So that is why you need logging. One is to find out whether any unusual activity is happening. Second, in the event of a system failure, you can actually read the logs and say what exactly went wrong and why the system went down. So logging is a very crucial aspect. Application security or hardening. When we talk about it, it is a very large topic. Many security features are implemented in similar ways across different platforms. Now the subtopics under hardening will be running as unprivileged user or a group, running in chroot jail, then the modularity of features, encryption, the login. So running as an unprivileged user. Every process runs as some user, whether it is a system process, whether it is a user process, it runs as some user under some account. The extremely important user is not root, always, since any bug can compromise the entire system. So if it is running under root, you can be rest assured that one bug or one compromise will bring down the entire system. The system may need root privileges, for example, to bind a port. You can have root parent performed privilege function but main service from unprivileged child. Say you are installing a particular software, you install it as root but assign the process or the task of running it to another user who is not root. The user and group use should be dedicated, that is for certain process and applications. It is easier to identify the source of log messages. So that is why you need to run it as a separate user or group, so that you will say that from this particular user or this particular group, this particular event has happened. So it is very easy to identify from logs. Running in chroot jail, chroot confines a process to a subset of root. So it maps a virtual root to some other directory. Directories outside the chroot jail aren't visible or reachable at all. It contains effects of compromised daemon. It is complex to configure and troubleshoot. Now, for example, if an FTP daemon serves files from a particular directory, let's say that some IP address x.x.x.x/ftp/public. There shouldn't be any reason for that daemon to have access to the rest of the file system. So it should be confined to that particular path. The modularity, when we see application running as a single large multi-purpose process, can be more difficult to run as an unprivileged user. It is harder to locate or fix security bugs in the source. It is harder to disable the unnecessary functionality. So the modularity is a high-priced feature, providing a much smaller attack surface. Now, if you take, for example, Postgres versus Sendmail or the Apache modules, you will understand about modularity. Encryption, sending the logins and passwords or application data over the network in clear text exposes them to various network eavesdropping attack. So that means in clear text, in the sense it is not encrypted, it goes in plain text. Using eavesdropping attack, suppose you use a Wireshark for sniffing the traffic or some other tool. So many network applications now support the use of SSL and TLS protocols in the OpenSSL library used. OpenSSL itself is prone to a vulnerability which can be fixed. I think most of you will know what the vulnerability is. We will ask an assignment question on OpenSSL vulnerability. You may need to own X.509 certificates to use. It can generate or sign using the OpenSSL command. It may be a commercial, or it can be your own, or it can be a free certification or certificate authority. Again, we come back to a bit of logs. Applications can be configured to log at any level of detail. Debug is to none. None is no logging. Centralized logging using syslog can be used for consistency. Now, why I have put syslog is, if it is for a small network, you can use syslog. If it is for a large network and you need support in managing or fine tuning it, you need to go for a tool like an SIEM tool. And you must ensure there is some form of logging management, as discussed, like rotating. You should have proper policies. You need to know what devices you are going to configure. So the SIEM basically does again the task of collection. It collects all the logs. Correlation arranges in order of the device and in a timestamp fashion. Analyzes, it analyzes the logs, or it presents the logs in a more readable fashion, and then it reports based on the industry requirement or regulatory requirement. It will give you a nice good looking report with lot of graphs, lot of pie charts,